Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph a couple of rational functions that are not in lowest terms, meaning that the numerator and denominator share a common factor. So before we go looking for vertical asymptotes, we have to make sure that the function's in simplest terms. And so if we look at this example where we have x squared minus 4x minus 12 over x minus 6, this numerator factors to be x minus 6 times x plus 2. And the factor in the denominator is also x minus 6. So there's not going to be an asymptote at x minus 6 because when we simplify this is really the same as the function x plus 2, a linear function, with one exception. The original function is not defined when x is 6 because you can't divide by 6. But it is defined, the second function is defined for x equals 6, and so we have to leave that point out. When we look at x equals 6, f of 6 would be 6 plus 2, or 8. And so the point 6 comma 8 is going to have a hole in the graph. So first I'm going to put the hole on the graph at 6, 8. And then the function was x plus 2, so that's a y-intercept of 2, up 1, 1 to the right, up 1, 1 to the right, and so on. Continuing to the left. Anyway, we get a graph that looks like this with that hole shown. So in terms of domain and range, the domain here would be everything except for 6. So negative infinity, comma 6, union 6, comma infinity. And the range would be everything but 8. So the range, negative infinity, comma 8, union 8, comma infinity. Like that. Okay. So again, we had a rational function where the numerator and denominator shared a common factor. The simplified function was linear, so we graph it putting a hole in that one location. All right, let's do another one that's not going to become linear, but it does have a common factor situation as well. X squared minus 4 over x squared plus 3x minus 10. The numerator is a difference of squares, so that's x plus 2 times x minus 2. The denominator is factors to be x plus 5 times x minus 2. And when we divide out the common factors, we're left with x plus 2 over x plus 5. So that's a rational function, and we've got to find the asymptotes for that. Also, there's going to be some kind of a hole at x equals 2, and we'll have to figure that out as well. All right. So first, if we just consider the simplified function, notice that the denominator has x plus 5 in it. That tells us that the vertical asymptote is going to be x equals negative 5. So I'm going to put that on the graph first. Like so. Then, if we look at the numerator and denominator, those have the same degree. So the horizontal asymptote is going to be y equals 1 divided by 1. The coefficient of the leading term is 1 in both cases, and 1 divided by 1 is 1. So I'm going to put the horizontal asymptote at y equals 1, like that. Zeros come from the numerator. That's where x plus 2 equals 0 or x equals negative 2. So we're going to have a point there. We've got a couple of choices here. I could graph the hole. I could try to figure out if the graph crosses the horizontal asymptote. Maybe I'll do that first. Does it cross? Well, if it crossed, that means that x plus 2 over x plus 5 would be equal to 1. or that x plus 2 would equal x plus 5, but when we subtract x from both sides, we're left with a contradiction. 2 cannot equal 5, so it's not going to cross that. And that pretty much tells me that the bottom right quadrant is going to contain one branch of this graph. I should find the y-intercept. I haven't done that yet. Again, that's where x is 0, so f of 0 equals 0 plus 2 over 0 plus 5, and that is 2/5, or a little less than 1/2. So if half is halfway, it's going to be a little below that. And I do need to figure out, the whole is at x equals 2. So for the simplified function, that's going to be 2 plus 2 over 2 plus 5, or 4/7. So there's going to be a whole at 2 4/7. And I could, actually, let me make that whole like that, so I can see that a little better. I could add some more points by, say, maybe plugging in -3 or -4 to get a more accurate graph, but since I'm just going for a rough sketch here, that branch is going to look like that. Now, is it there? Or is it there? That's what we're trying to figure out next. And one thing that we know is that there are no more x-intercepts, and it doesn't cross the horizontal asymptote. So it can't cross anything to the left of that, meaning it's not, but it's going to approach that line. So those two things are contradictory. So we're pretty sure that the graph's going to be up above to the left, but what we can do is plug in a value to the left of -5, like -6. So let's try that. When x is -6, the function would be -6 plus 2 over -6 plus 5, and that's -4 over -1, or 4. So we know we got a point there. And we could plug in more values if we wanted to, like -7. If you plugged it in, you would get -2.5. Anyway, we have a good idea of how that one behaves. It's going to be something like that. The domain is -infinity to the vertical asymptote at -5, union -5 to where the whole occurs at +4, union 4 to infinity. The range would be from -infinity to 4/7, the y value, the y coordinate of the whole. And then it's going to be between the whole and the asymptote, which we know isn't a lot of room, 4/7, 1, and then finally from 1 to infinity. All right, so there's a couple of examples of what happens when the numerator and denominator have a common factor. We graph the simplified function, but then we have to go back and put in a whole because the function is not defined in those locations. All right, that'll do it for this section. I'll see you in the next chapter.